So we're going to kind of review water on Earth, and then we're going to talk about how where we tap into this water, what we use it for, and then starting tomorrow, you'll start to talk about the problems with, or global problems with water. So this is review. The water cycle, you have to know the full water cycle. I'm not going over that again. What I am going to go over is, what's number 5 here? That's not written. So when precipitation falls, there's this blue water pouring down. What's it going through there? Nope. Infiltration. Good. Once it hits here, it's percolation because we're going through the rocks. And then what's this blue thing called? Aquifer. And I want you to add to the aquifer maybe like a nice blue flowing water all the way over here, because we know aquifers run off, right, into large bodies of water. You want to remember that. So you've got your evaporation, condensation, precipitation, and what's this? This dotted line here. Runoff. Surface runoff. You want to remember that too. So we've got surface runoff right here. We've got infiltration right here, percolation into an aquifer, and then runs off into a large body of water, which in this case could be a lake or an ocean. Now, how much of Earth is water? 70. Also review. So we're distribution of water review. How much is marine? 97. Fresh? How much of that fresh is trapped? 90. About 60, right? Trapped, I mean glaciers. Aquifers, not trapped, but hard to tap, about 30. And then the easily accessible is less than 1%. And I know this doesn't add up to 100. It's an average, okay? There's no exact numbers. And really what you want to know is that less than 1% of our water is easily accessible water. And obviously 70% of us is water. We depend on water for everything. So we're going to talk about this little water, how we get it, how we use it, all of that. So the water that we tap into for our daily use comes from 2 main sources. The first one is surface, the one that's less than 1%, which is lakes, rivers, streams, ponds, all these things. It's going to be replenished by snow melt, or what 2 parts of the water cycle? Precipitation and runoff. Good job. Because if water infiltrates, where is it going? Yeah? Okay. It'll eventually run off, but first is surface runoff or precipitation. Oh, this one. All right. So I forgot to record this. Watershed is basically when like pockets in the land that flow into a large body of water. And we call that reliable runoff because we depend on that land formation to easily replenish surface water. We've affected it through urbanization, building of roads, construction, changing that flow of water. Our second source of water we tap into is aquifers or groundwaters, or what we call underground rivers. And how are aquifers replenished? They're replenished through infiltration and percolation. So like surface water gets replenished through watersheds, or reliably replenished, we replenish aquifers naturally, as we mentioned before, through infiltration and percolation. But they can also be replenished through what's called lateral recharge, which is going to take a body of water like a lake, and the lake flows into the aquifer. So it's kind of like a reverse flow, and it's sideways because you have a lake that's connected to an aquifer and it's going into it like horizontally, versus if it's infiltration, it's going to go into it right vertically, and that's natural recharge. We measure the levels of water. When we say water is plentiful, that means there's a zone of saturation, or the aquifer is packed with water. And we measure it by measuring the top of that zone, which is called the water table. So whenever that top layer is low, we are in what we call critical water shortage. And that's where they start, making water restrictions, which you haven't seen or you don't recall in your lifetime, because the last one you were probably like 7 or 8, yeah?
It mattered on your zip code.
It mattered on your zip code whether you could water your lawn, wash your car, turn on your sprinklers. All those things had restrictions because the water table was so low. We just talked about water table and water restrictions. You gotta think, okay? that water access, you take it for granted because we turn on our faucets and we have water. There's places that not only do not have access to water in the world, they don't have access to clean water. So not only can you turn on the faucet whenever you want and water pours out of it, okay, your water that pours out of it has been filtered. There's places with no faucets, no water, and when they have access to water, it's filled with bacteria or you know, disease-causing agents. So think of that. And honestly, even in the U.S., they predict serious water crisis coming up in the future. There's specific states that have no water right now and that they're tapping into other states for water. So we too have seen a little bit of that crisis. So the idea is first learn where we use water or how we use water. We know where we get it. How do we use it? And then how are we going to make this usage better? Okay. So how do we use water? Global water use. Number one thing is what? Agriculture. Number two, factories or industry. And I want to use that word and kind of tap on this. Archbishop McCarthy is not an industry, it's a business, right? Businesses are all over Pembroke Pines, all over Southwest Ranches. Industry not. Industry is a coal-powered plant, right? We have some concrete manufacturers. That's industry. The other percent, which is 12, even though it's municipal and you think of that as your home, and there's obviously a home there, businesses will fall under that category. So for industry, you want to add the word manufacturing of goods, because that's what an industry is, a major factories, okay? Because they use water differently than home water use. We're going to dive into each one. So agricultural's number one use for water is for what?
Watering plants.
Watering crops, right, or plants. And the biggest problem with the irrigation system is that the water oftentimes evaporates before it even hits the ground. So the inefficient, try to start using that word as much as possible in this class. Efficient systems matter because what you put in should equal what you put out. Remember the throughput? We talked about it with energy, but it's with everything. So why should we put tons of water into a system if they're not going to end where they need to be? So that's something we're going to talk about in a minute, is improving irrigation systems. In the industry, we use water for three main things. What are they? What? Powering. So generating power. You said cooling, and that's true. Our coal-powered plant uses water to generate power. Our nuclear power plant uses it not just to generate, but to also cool the plant to avoid any kind of meltdowns. What else do we use water in the industry for? Cleaning or good. Manufacturing and cleaning or sanitizing, all necessary in the industry. All right, I forgot to show you this little graph, and it's always important to kind of look at, let me actually cut this and bring it to the front so it takes up. This graph shows you worldwide use of water, and it's comparing developed countries and more developed countries, or developing and developed. And obviously in developing countries, agriculture is going to win and very little industry because they don't have industry. And then you look at developed countries and its agriculture becomes a little bit less than industry. But overall, agriculture is going to win in overall use. But it makes sense. The more urbanized you get, the less farmlands there are, right? So the less agricultural society there is. All right, at home. What's the number one thing that uses water in or at your home, I should say? Nope, but I'll give you shower will be the third one. The toilet is the second, but inside the home, it's number one. Washing machine is here with faucets. Drinking is limited because people buy a lot more bottled water, but you get it from the faucet, you put it in the refrigerator, right? That's considered the same as drinking. What uses the most water in your home, guys? Sprinklers. Landscaping. Watering your car. I would say outdoor use in general, not just sprinklers. Sometimes you use the water to fill up a pool. And then the last one, anybody can decipher what this is right here, this picture? Leaks. Big problem, right? Before we get into problems, like I used to cover this at the end, but realistically, I want you to really think about the fact that you're so lucky because when you turn on your faucet, you have water that has already gone through some treatment. There's a lot of places that don't. We filter water, or your city filters water for you because it's trying to make it so that when you drink it, you're not going to get sick. And it's removing a lot of disease-causing agents or heavy metals or salts or so many things that are in our water, because everything you do, when you clean your driveway with Clorox, okay, where is that Clorox going? It's going to go to, it can go to the sewer if the flow of your water is correct, but where else can it go? Into a lake, because it can infiltrate and percolate through your soil and end up in an aquifer and end up in your lake. So everything that you do is going to affect your body of water in some way. So we have to be really grateful for the plant. Sadly, not only do we have to be grateful for the plant, we have to learn this whole entire process in order, okay? So,
did we have to know
no. Nothing of that. That's just popping up. You want to know that we are going to make water drinkable by removing pathogens or any kind of pollutants that can affect water or affect your health. So the first thing that when water gets tapped into Lake Okeechobee, which is, I'm saying like our water plant, it's going to go through a filtering system, which is basically like big screens to remove large debris, fish, leaves, anything that I know, sadly, that entered the plant is going to stay on the top of the screens, and the water is going to trickle down as you see here and then be taken to the next system. The next system can be, it's not just adding aluminum, it's a whole process. It's a tank that's like processing water to remove bacteria, which is our biggest fear, right? We don't want any disease-causing agents in our water. So coagulation, which is a vocabulary word, right? Second part of a water purification, they add aluminum, and you have to know that, which is Al, in case you forgot. And they add that to remove like any more sediments and bacteria in the water. Then the water is going to go into another like big pool, because these are all like huge pools, and it's going to get filtered more. But the filtering is different because now the sediments are going to drop to the bottom and the water is going to pour out of that pool clean, right? Hopefully. 3 more steps. 4th step is chlorination. What do you think we're going to add here? Chlorine. Have you ever smelled chlorine in your water?
Yes.
Why do we add chlorine to the water? Good job. We want to kill, and we already killed it with the aluminum, right? And the coagulation, but we want to make sure no bacteria regrows in our water, because from there, it's going to go through 2 more phases before it ends up in your house. Here. But our water doesn't have a lot of chlorine, but look at, it's a big process. It's, again, tanks pouring chlorine, and then they're going to go through this. This is where some plants do not process. So they might end right here, and then we get these, which aeration towers. They're going to force air into the water to remove what? What do you not want in your water? We already killed the bacteria. We removed all the debris. We made it clean, but what's missing? Possible what? What do you never want to pick up a cup of water and...
What's it called?
We removed everything. All the bad products, right? Smell. You don't want your water to smell, right? When water smells, you don't want to drink it. And you want it to taste better. So literally the aeration towers kind of separate molecules. And what you end up with is drops of water, okay, that are going to pour out. Not always through a tower. Sometimes it's through tanks too. The process is the same. And then from here, there should have been a little connection here. It's going to go here for additional treatment, which our water plant actually adds fluoride. So not for flavor, but for your actual gums and healthy teeth. No, it's bad in high quantities. But now when you go to the dentist, they won't add fluoride at the end of your cleaning because they know it's in our water and that it's already enough. So they don't need to keep adding. From there, it's going to go through pipes into these tanks that are stored and then eventually come to your house through pipes.